next question is one that everyone asks. I mean, just look at all these letters. And all of them ask the same question. Why is the sky blue? Here to answer this classic question is Dr. Lawrence Rudnick, Professor of Astronomy at the University of Minnesota. Welcome back, Larry.
Hi, Dan.
All right, don't make me sing the tune here. Okay. But you get the question. Why is the sky blue?
Well, if we look out in space, we see the sky isn't always blue.
That's true. It's black.
Right. So the atmosphere is the first key.
But it also reminds me that at night the sky isn't blue either.
Right. That's the second key. So we need both the sun and the atmosphere of the Earth in order to give us the blue
All right.
sky.
We've got light. We've got an atmosphere. What is it when the two combine that gives us a blue sky?
Well, in order to answer that question, we need to repeat an experiment that Newton did a few hundred years ago, where he looked at sunlight. And what we want to do is take a little sunlight here.
Classic question back a few years.
Right. Here's our model sun, light shining in. What Newton did and what we're doing here is putting light through a prism.
Through a prism.
Oh, and what I'd like you to do is to hold up this card so we can see the light that comes out of the prism.
That's very nice. It's always great to be reminded there's all this color and white light.
It's beautiful to look at. For our purposes, the key is to understand what is different about these different colors. Light is actually a wave. And when we look at blue light, we are looking at waves in which the crests are very close together, and we would call that short wavelength light.
Okay, so the blue is at the short wavelength end of the spectrum.
Right,
Okay.
and the red waves, on the other hand, have their crests much further apart, and we would call them
longer waves.
longer waves.
All right, what's that have to do with the blue sky?
Okay, it's the interaction of them with the atmosphere that's really important. So in order for us to see that, what I'd like to do is to shine our light into a model atmosphere. So here I've got a tank of water. It's about to become an atmosphere.
What do we have to do to get it to be an
We
atmosphere?
have to put some molecules in.
Okay.
So if you will take some of that skim milk, and these molecules of skim milk are going to
Pour right in?
pour right in, stir it up, get a nice atmosphere here.
Kind of a foggy day out here, Larry.
Well, not yet. Well, I want you to look and see what's happening. And what do you see?
Oh, look at this. We're getting this blue haze right here in the
Exactly.
model atmosphere. And when you say molecules in the atmosphere, you're thinking of things like nitrogen, oxygen,
Exactly.
the chemicals that make up our atmosphere.
Right. Now, what's happening is that there are some molecules, like water vapor and ozone, which are scattering and absorbing some very specific wavelengths, some very specific colors. But the effect that you're looking at here is slightly different, and what's responsible for the blue of the sky is an effect which doesn't depend on the composition of the molecules, what they're made of, but in fact their size really is the key. And the effect is that when you take a long wavelength wave, like the red light, and you pass it by small molecules, it just goes right on through.
No real effect.
No real
So
effect.
the red light
Small
here is
effect.
just passing right through.
Right. On the other hand, if you take short wavelength waves, like the blue waves, and pass them through these molecules, some of those blue rays bounce off. And in fact, about 10 times as much of the blue light bounces off than the red light.
And that's the scattering that you're describing.
And that's the scattering, and that's what gives us the blue sky.
Okay, so we've got the color then. We know why the sky is blue, but think about this for a minute. When you're standing on Earth, like you and I are most of the time, we look up at the sky, the whole sky is blue.
Right.
How does that happen?
Well, in order to understand that, you have to picture yourself inside the atmosphere, which we are. So what I'd like to do is to take you inside of our model atmosphere.
We go inside the tank?
Sure. Here we go.
Okay, Larry. Good trick, Larry. We're in the middle of this blue suit. Right now what?
Well, look, the sunlight is coming in from over here. So the light is coming, and it's hitting molecules in the air and reaching your eye. And so no matter where you look, there is sunlight which is bouncing off those molecules and coming to you.
Oh, this really has to do with where I'm located.
Right.
So the blue, the fast wavelengths come in, strike one of those molecules, get scattered, and then come straight to my eye. Same thing if I look over here. There are some that are scattered and hit my eye.
Right. Wherever you look, you're going to see some of it.
Perfect. That's why the sky is blue.
Right. You got it.
But Larry, the sky isn't always blue.
True.
Sunrise, sunset, sometimes we get a very orange or red sky. What's going on there?
Well, David, you actually know enough to answer that question yourself. Let me take you down to the end of the tank. We'll take a look at it and see if you can figure it out.
I have to figure it out. Okay. Oh, this is beautiful, Larry. That nice golden sunset. That's
Right.
perfect.
Yeah, and we're at the end of the tank here, and we're looking back towards the sun shining into us.
And I have to figure this
Now
out.
you
All
got to
right.
figure it out.
You told us earlier that if we scatter all that short wavelength blue light,
Right.
basically all we're going to have left is the orange and red end of the spectrum, right?
Right.
And that's what we're seeing.
You've gotten it. Mostly the light that's left is the orange and red.
Okay. Now, why at sunset?
Well, the sunset is when it's going through most of the atmosphere. When the sun is low on the horizon, then there's a lot of atmosphere for the sunlight to come through
Scatters more blue.
and leaves more red, and that's what gives us the beautiful colors.
Perfect. You answered both of those questions wonderfully, Larry.
Right.
Thank you so much.
Right,
We need
okay.
to get out of the tank now so we can do the rest of the show.
David, I thought you were going to do it.
You're kidding me. You got us in the tank and you don't have...
Oh, boy.
Did you bring a snorkel?